Suppose we want to find all the integer solutions to x1 plus x2 up to xn equal to k, with each xi larger or equal than 0. We've seen this before. This was essentially how can you distribute k cookies among n children, where each child is also allowed to not get a cookie, right? And we saw how to solve this. It was using the stars and bars. So a quick recap of that. The idea was that the stars was the cookies and the bars was the number of children minus 1. And so the idea was that if you did like a 2 stars and a bar and 2 stars here, a bar, and 1 star, this is representing 3 children, where the first one gets 2 cookies, the second one gets 2 cookies, the third one gets no cookie, and the fourth one gets 1 cookie, right? And so in general, we have, so here the number of cookies is equal to k, and the number of children is equal to n minus 1. And so the total number of symbols, is equal to n plus k minus 1. And we need to see all the ways that we can choose where we position the bars. So the solution to this was n plus k minus 1, choose k, right? So we already know how to solve this, and this is a nice counting technique for doing that. Now we're going to show how to solve it by using generating functions. So the way we do that is we need to associate a generating function to this problem. And so now the way we do that is we can think of the following. Consider a polynomial counting the amount of cookies that the first child has, and you multiply this by a polynomial. Essentially, this is going to give us the generating function for amount of cookies that the second child has, and so on. And you do this for all the children, right? So essentially you have n multiplications going on here. So in other words, this is just 1 plus x to the power of 1 plus x to the power of 2 plus x cubed, so on. It's this infinite sum to the power of n. And so this is going to be the generating function for our problem. If we open this up, so let me just write it like this. If we write this as summation of an x to the n, here, let's use a different ai x to the I, so that we don't confuse the n here, equal to 0 to infinity, then this sequence ai is essentially counting the solutions to our problem, right? It's counting how many ways we can do that. Okay, so how can we solve this? Well, 1 plus x squared to the power of n. So we already saw that we can write this sum here is going to be just 1 over 1 minus x, and so this to the power of n. But now this is just going to be 1 over 1 minus x to the power of n. And we just saw the generating function for this, right? We saw that the generating function for 1 minus x to the power of minus n, or 1 over 1 minus x to the power of n, is this one over here, given by the n plus k minus 1 choose k. And so this is just going to be summation k equal to 0 to infinity, n plus k minus 1 choose k, x to the k. which means that our number of solutions is just going to be equal to n plus k minus 1, choose k. So this is another way of solving this problem. There are advantages to one way or the other. So of course, I think the more combinatorial way has the advantage that it sort of shows you better why the thing is true, but it requires some creativity. Coming up with that whole stars and bars technique and doing all of that requires being a bit creative, I would say, whereas the generating function approach is much more mechanical.